Hi everybody, this is Mrs. Dinkelman, and I'm just going to go over a little bit of advice, and I will probably go through some of the work associated with what's happening in this FRQ booklet. I'm going to apologize in advance for having to do it using the document camera because it's probably going to like focus in and out as I move stuff around, but I guess we will deal with it. So if you haven't already grabbed this packet, this is the kind of the advice on a graph analysis problem. So that's what the free response is going to be like tomorrow, so Friday, when we do the first try, second try. Little explanation there. I know you can read, so I'm going to let you do that, and then I'm going to kind of just move this around as we fill it out. So you already have this helpful table. It's something that we filled out a long time ago, but if you want to fill it out again, I'm going to talk through it again. So just a quick reminder that if f is increasing, what we know is that f prime is positive. And when we say positive, what we really mean is that the y-coordinate on the graph is positive or looking above the x-axis, or in the case of decreasing, below the x-axis. So decreasing f prime would be negative. And these words would be things that we would use also in a justification if they ask us about where f is increasing or decreasing. A local max would be, we would kind of probably want to say a couple things. So I would want to say that the derivative is 0 or undefined. And then I would also want to mention that sign change. So I need the sign to change from positive to negative. Again, if it's helpful to think about increase to decrease is what's really happening for the maximum. We would want to use probably the word f prime or the derivative again in a justification and not say it changes from positive to negative because the reader or grader won't necessarily know what we're talking about. Since I don't have a lot of space here, I am going to use the plus and the minus, but if you have space, I would write it out just in case. So local min, very similar. We want the derivative to be 0 or undefined. This time the change, though, on f prime is from negative to positive. The other thing that remember we could do, and that's with the second derivative test, is we could know that we have a critical value on f prime, so that we have a 0 or undefined on f prime. We would have to do that first. And then we would plug those numbers in and see what the concavity of that function is doing at that time. So if we have something that's concave down, we would know we have a maximum. So that would mean that the second derivative is negative, and we could use words there. That is a second derivative there. For a minimum, then we would want something that's concave up. So that would be the second derivative is positive. Again, you could use words or the inequality there. Okay, I'm going to slide up a little bit here. Again, sorry about the focusing or lack thereof. So I'm on the concavity and point of inflection. I'm going to look at that last column first because that's my favorite way to find concavity if I can. So on concave up, we would just be saying that the second derivative is positive. And I guess I could just write the word positive here like I did earlier, but I just kind of wanted more info. Concave down, second derivative is negative. And then on that last one, point of inflection, what we really have to know is that the second derivative changes sign. There's also another technicality, and that is that the first derivative has to exist, but that is never tested on the AP exam. So if you want to add that, you can. If you don't want to worry about it, that will be fine. So we could also look at the first derivative to tell us about concavity. So if the second derivative is positive, that means our first derivative is increasing. And another way to say increasing is that our first derivative has positive slopes, if you like to think of it that way. If our second derivative is negative, then our first derivative must be decreasing. Again, if you had said negative slopes there, that would be fine. It's just decreasing is a little bit more mathy. And then what would happen for our points of inflection is our slopes would change sign. So kind of the faster way to say that would be that there's mins and maxes on F prime. Mins and maxes on F prime. The way my brain thinks of it is that the slopes change sign. So I would go from a positive slope to a negative slope or vice versa. I should say slopes of F primes. So slopes of F prime. Again, always be really specific about that so that they know exactly what you're looking at. Don't say it. Don't forget to be specific about that. Okay, on to the second page. I'm going to get a different one because my marker went through. Sorry, just give me a moment. Okay, a little bit about justification and what you need to say. Most of the time, justification just means you need to show your math work, but on these min-maxes, they do require a little bit more sometimes. So function increasing or decreasing, so we would want to say, again, something like f prime is greater than 0. That would be for increasing. And we would want to say f prime is less than 0 for decreasing. It doesn't have to be in sentence form, it can be in those math symbols. The local max and min, however, does need to be a sentence. So let's just pretend there's a local max. And maybe we'll just make up a number just so that we can use that in our sentence. So let's say there's a local maximum at x is 3. And let's talk about how we would write that sentence. So I would say something like that. So local max at x equals 3 since. And I like to add that the f prime, the derivative is 0 there, but technically I feel like you wouldn't have to because if the sign is changing from positive to negative, it kind of has to go through the 0. So since I'll say the derivative is 0, and I'm going to say it again, and the derivative, so they know I'm talking about that still, changes from positive to negative. Okay. For absolute maxes and mins, so I like to draw a picture here. Remember, sometimes calculus will find us the absolute maxes and mins. So in this case, calculus would find us that absolute max, but the absolute min would be at an endpoint. And so if we only used calculus, we would be wrong because we would have identified that local min. So what we have to do is we need to identify the endpoints. So let's just kind of make those up for a second. Let's say we're wondering what the absolute max and min is from 1 to 10. Okay. What we would want to do is make a list for ourselves. We would want to make sure that we provided 1 and 10 on our list, and we would plug those into the original function. And then we would want to identify any critical values. So let's just pretend like we found that f prime of 5 was 0. So we would want to add that to our list. And then we would literally be looking for which one of those gives us the highest y-coordinate and which one gives us the lowest y-coordinate. So in this case, justification really is just the math work. So points of inflection, that last one, how do we justify? Again, technically there's 2 things that need to be met, but for the AP exam, we can just say, and again, let's just make it up. So let's say that there's a point of inflection at x equals 2. So we'll say that. Point of inflection at x equals 2 since the second derivative, and just by the way, if you didn't want to write the word second derivative here, or if you didn't want to write the word derivative up here and you wanted to use like y prime or f prime, you could do that. I'm just going to say the second derivative changes sign. Again, there's a couple other things like f has to exist, actually has to be a point on the original. So let's just say f of 2 didn't exist because there was an asymptote. We would have to throw it out. Okay, these next bullets are just kind of a by the way. These are kind of some of the things that the AP exam will ask you to do on a problem where they give you a graph of f prime usually. So they'll ask you to find slopes or second derivatives, acceleration. They'll ask you to write the equation of a tangent line or do Riemann sums, or sometimes there'll be actual geometry curves, kind of like the ones we've been looking at lately. They oftentimes have some form of integral on them, so that's what the next two bullets are about. Again, area under the curve, or just knowing the relationship between f and g if one's the integral of the other. We will not be seeing integrals on the one for Friday just because I feel like we're not quite ready for those yet. So don't worry about those last two, but definitely save this packet or maybe put it in your file so that when you start studying for the AP exam, you can look back at those. The next few things here are just some practice problems that you can work through, and it does have the rubric attached. So let me just give you advice on the rubric as far as I'm grading it. So on the right, I think is the easiest spot to look first. So this one says that you earn 2 points for having f prime of pi correct. And really, if we come over here, that's just having the -1 in this case. So yes, they put lots of information here on the left. They are mathematicians, they are teachers, so they want to make sure they communicate everything. But on the right, it tells you how much of that stuff you really need to have. So I'll do a few of these, and then you can let me know if you have any questions on any of them as well. So on A, the slope of the tangent, what I'd be really looking for is really f prime of pi. So up here, just where I have a little bit more space since it's kind of scrunched in, I'm going to go ahead and find the derivative of f. So derivative of cosine is sine, leave the inside alone, and then multiply by the derivative of the inside. And for e, it's e to the stuff times the derivative of the stuff. So then I'm just going to plug the pi into that. So sine of 2 pi is 0, and e to the 0, and then cosine of pi is -1. So that's how they get the -1 there, because e to the 0 is 1. On letter B, I'm going to try to sneak in, this is really a chain rule problem when I'm trying to find the derivative of k, because f lives inside of h. It's not multiply. If it was multiply, h would have his own x. So this is derivative of the outside, leaving the inside alone, times the derivative of the inside. I'm going to not put an equal sign there. I'm going to put it up here. So k prime of pi is going to be h prime of f of pi times f prime of pi. Luckily, I already did f prime of pi from earlier. So let's see, f of pi coming back up here. Cosine of 2 pi is 1. And then sine of pi is 0. So we just get 1 for that. I'm going to take another step here. Let's see, f prime of pi was -1. So now h prime of 1, I'm going to have to come look at my graph. I need to look at 1. I really want the derivative right here. So I have to remember that since I was given h, if I want the derivative, I'm going to have to look at the slope of this line. So this line looks like it goes down 1/3. So let's see here. Let's finish this out. -1/3 times -1, so +1/3 for that one. Letter C is just asking us to do it's kind of a chain rule and product rule at the same time. So let's find m prime of x. And so we would go first times the derivative of the second plus second times the derivative of the first, g prime of -2x. And then don't forget, chain rule means we multiply by that -2. And then we would plug the pieces in there. I'm trying to see how much room I have. I'm going to go letter C right here. So I'm going to need g of -4 and h prime of 2 plus, and then h of 2 times g prime of -4 times -2. Okay, so let's see if we can find those pieces. So up here, it's kind of hiding, I know. G of -4 is 5. H prime of 2. So we're back over here, but we need the derivative, so that's that -1/3. H of 2 would just be the y coordinate at that location, which is a little bit tricky, just because we kind of need to know what that slope is. Obviously, we know it already, but unfortunately, it's not a very nice point. So let's see if we can write that down. That's going to be 2, comma, and I don't know. I'm trying to think if I just want to try to figure out how many it goes up and over, if I'd rather write the equation of the line. So I think h of x for that particular location would just be -1/3 x. And so I'm going to plug the 2 in there and just get -2/3. Okay, so let's see. -2/3. G prime of -4 was given. That's up here on the table. So that's that -1. And then times -2. Remember, technically you're done on the AP exam if you want to be done there. So I'm just going to go ahead and keep going. So this is going to be 5/3, and it's negative, and then -4/3, which is -9/3 or -3. And I kind of covered up that last one, but this says G prime. This is actually the MVT. And so it's helpful to talk about on the MVT. There's a couple things you have to do. You have to name the theorem, and you have to make sure that you identify that it does work because you have a continuous differentiable function. So let's see. Let's read earlier. I'm going to read this line right here, which says, let G be a differentiable function. So let's first state that G is differentiable, which means it's continuous. Because if it wasn't continuous, it wouldn't be differentiable. Sorry, I was off the screen there. So I was writing G is differentiable, which means it is continuous. I should probably put G instead of it there. You guys can -1 for me. Which means, and you're okay using MVT applies. And then the other thing we would want to show is that the conclusion, that derivative really should be -4. And the way we're going to do that is by finding the old slope guy. So the y2 minus y1 over x2 minus x1. And we know that x2 and x1 are that 3 and -5. Sorry, -3 and -5. And so I need to know what the y coordinates are for those. So let me come back up to the table. So at -5 we have a 10. And at -3, we have a 2. So I'm going to put those y coordinates in here. Okay, so at -3, it was 2, and then it was 10. And so what we really have is -8 over 2, which is -4, which is exactly what they gave us for that G prime. We just want to make sure those match up. Okay. So if we look back at points, we kind of talked about this one. Number 2, just showing that you know the chain rule and how to evaluate. Product rule and how to evaluate. And then showing that you did the slope formula, but also this justification where you talked about the mean value theorem applying. Okay, I'm trying to think of, I don't want to go too long. I know you could fast forward by me as well if there was another one I should look at. So let's just go ahead and do the second one, and then I'll leave the third one for you to do.
Attention students, there is a slam dunk contest in the tech gym at lunch. The hoops have been lowered to 8 feet, and there are prizes. Also, there are paint out shirts for $7 and lanterns at home for $3 for sale outside the library.
Okay, This one is one of the ones that has a relationship that we haven't really talked about yet, but I'm just going to zero in on this a little bit and just remind you that what would happen is if I took the derivative of both sides here, that g prime of x would equal f of x, and we'll talk more about that relationship soon, but that might be helpful as we answer some of these questions. So on A, where it says, does G have a min, max, or neither at 10, what we would want to first do is figure out what's happening with G prime of 10 and whether it's a critical value or not. So what we have to do is determine whether, again, this relationship, let's think about area, because to find G, I would have to find the area under F. So let's look from 2, because that's what this says. We start at 2 and we look beyond. Again, this is not a problem that you would have to do yet because we haven't talked about it. But I hope you will agree that if I have this triangle and I add those two areas together, I would get a 0. So again, from 2 to 10, I'm thinking the area is 0. So it really is a critical value at 10. So it is a candidate for being a min or a max. And then the other thing we could see here is that our area, I guess it's lunchtime. The other thing we can see, what we should look for here is whether the f of 10 does change signs at 10. So if we look at 10, because we have something that's not changing sign, it goes from a negative to a negative, it would be neither. So you can kind of see the justification. I have a lot of space on this one, so I'm just going to point it out while I'm talking it out. You'll see here that it says neither, and that's because we have, I guess the way they're saying it is that F does not change signs, it's always negative. And I probably just write since I would definitely establish this relationship at some point, doesn't change signs is what I would say. Okay. On B, does G have a point of inflection at 4? So I would be trying to see what happens with G prime of 4. If we come back up here and look at the relationship I mentioned earlier, that would mean that G double prime is equal to F prime. So let's look at 4. So F prime or G double prime of 4 would not exist. So that means it is a candidate for having a point of inflection. And then what I need to happen, think back to that chart that we made, is I need the slopes to change signs, or I just need this to be a max or a min, and that does happen. So you can kind of see here that yes, we have a point of inflection, and they talked about increasing to decreasing, which is fine. You could talk about slope. I would be fine if you talked about the max min situation. This absolute minimum is not going to be one I'm testing you on yet because again, it's about area. But if I'm looking for the absolute max or min, what I want you to notice is they make a list. And so the endpoints are on the list, and then they're going to check anywhere where the derivative is 0. So remember back up here, f is the derivative. So you can see that they're going to add -2, +2, 6, and then they kind of threw out 10, which we'll talk about here in a second, just because I think there's a couple that you could throw out. For instance, here at 2, I don't think that's going to be a max or a min because the derivative doesn't change sign. So, oh, and I can see that they didn't add that one in there either now that I'm looking. Okay, so these two in the middle are from where the derivative is 0 and changes sign. Now I would be fine if you put the 2 and the 10 on there as well. And then the way they calculated these, just so you know, is just by looking at areas. And we will talk more about that. But again, this one is not tested this time. And kind of same with letter D, but I'll talk it out for just a second. We want to know where G is less than 0. Sorry, I'm off the screen. G is less than 0. Well, G is this area under the curve, And so I want to know where I could calculate the area under the curve to be a negative. Remember, our starting value would be 2. So we have to think about if we go backwards, we would have negative area. If we go forwards, it would be positive until we started going below the axis. So I can definitely see there's maybe some negative area over here eventually. Okay, I'm going to stop for now. Just take a quick peek at this last one. A little bit of integral in this one as well, which means we're not going to do it. I really like that very first one we did. I guess I have it over here. So some of the derivative stuff there. But remember what we're going to do on Friday is you're going to get a first try and then a second try. So that will really be a good study tool is to look at that first one and ask questions before we move on to the second one. Okay, email me if you have any questions, and then we will talk again Friday when we take the FRQ.